Hey everyone, this is part 12 of our Building with Claude API series. And in this video, we're going to talk about streaming JSON input when doing tool calls. Before we dive into the theoretical aspects of it, let's first practically see this in action. Over here, we have a Jupyter notebook called 12 inside of VS Code. You can find this along with the GitHub repo. The link is in the description. And this Jupyter notebook has a very simple setup. The code over here has also been simplified to easily understand the idea of streaming these input JSON events. I personally found the examples given in the official Anthropic lesson on the same topic a bit unnecessarily complex. So I just simplified it. In the Anthropic course, this lesson is called fine-grained tool calling. Okay, we are making use of Claude Haiku as our model. And the main thing over here is this tool call that we are going to be doing. This tool call itself, as we all know, has these two things that we need to set up. One is the schema and the other is the actual function call. Now, when it comes to the function call, it's just a mock call. We're just returning article saved. But what we want to focus over here is the arguments that it accepts. It accepts these two arguments, one called abstract and the other called meta. Now, the schema of the input is defined over here in the tool schema. We can look at that. For ease, I have also given an example schema just to get the point across. Basically, it accepts these two values, abstract, which is a string of the abstract of the article that we want to save, and the other is a meta object, which is a dictionary. It has word count and a review description. Now, the function itself is called save article, which will accept the abstract and this meta objects as input to save it in a particular format. Now, with that context, the schema itself will make a lot more sense. So here you have the name, which is save article, and description saves a scholarly journal article, and then the input schema is defined over here. Basically, you can see that it takes in abstract, which is a string, and then it takes in meta, which is an object that in turn takes in word count and review as the input. So the key takeaway here is the first input takes a string and the second input takes a dictionary. So this is the input schema of the tool function call. Now let's look at the actual prompt that we're going to make use of for the different variations of the Claude API call that we are going to do. The prompt itself is write a short abstract for a paper about the benefits of using AI in education. And we are asking it to save the article using the save article tool. Here we are being explicit about the tool use that it needs to do. Most of the time we don't need to mention the tool name that we wanted to use. Claude is intelligent enough to make the tool calls for us. But here we are being explicit. So this prompt, let's first pass it on to a regular blocking call. So here when we call client.messages.create, it's just going to take all the time it requires to do all the processing of the messages that we send and return back a result to us. So let's run this call now. We can see that it took about 3.4 seconds and only then we got a response back. And the response itself is, here we have a text block that says, I'll create an abstract about AI in education and save it using the save article tool. And then we have the tool use block. It itself is quite extensive because of the inputs that we are receiving for the tool use. Okay, we can see that the tool use that it wants to do is the save article tool, and we can see the input that it provides for us to call this save article. Okay, and it is over here. So we can see that it is providing this big input. It's basically a bunch of key value pairs. Here it's providing us the abstract, which is a key value pair, and then it provides us this meta object, okay, which again is a nested key value pair, because inside meta we have the word count and we also have the review. So this is the input, the JSON input that we have received to call this save article function call. Okay, so this entire thing is the JSON input. Now in a previous video we did see how we can make use of streaming to enhance the user experience of end users. Now we could do the same thing even when we make use of tools. Okay, so let's use the streaming with tool calls. Okay, so here we have streaming with tool call. It's basically the same call that we used to do before. The only difference is we are now passing in the tool. Okay, so let's do this and see what kind of response we get over here. As we stream the different chunks that we are getting, we're just printing it based on its type. So let's run this and see what this returns back to us. I'll just zoom out a bit so that you'll be able to see all the chunks streaming in. So here, let's run this now, and we can see that immediately, it did give us a response. Okay, but if you observed, an interesting thing happens. So I'll run this once again. You can see that the first text came out, and then you can see the first key value pair alone appeared, and then the next key value pair appeared. Okay, so let me run this once again for good measure. You can see, okay, see this first key value pair is what appears first, and then the next key value pair pops up. Now the thing is, it has already started streaming the response back to us, so that's a good thing. Rather than us having to wait the entire 4.5 seconds, it is actually streaming the response back, so that's a good thing. It's just that the JSON input is coming in as key value pairs. So especially for a key value pair which is quite big, like for example here, it took a bit of time to give us this response. Now if this user experience is fine for your applications, it's well and good because it's already streaming. But if you want to enhance this and have more fine-grained streaming happening, there is a way to do that. Okay, we can do that by means of introducing this argument called betas. The value that we need to provide is fine-grained tool streaming and this particular date. Basically a string that we pass into this, and the API call itself needs to include this beta. So it looks like this particular call is in beta stage right now, but by means of using this variant of the call, we can pass in this fine-grained tool streaming value. And once we do that, if we now do the same call, you can see the difference. It's the same messages that we are sending in and the same tool schema. When we run this now, we can see even the JSON input is streaming. It's not waiting for the key value pair to get completed before the response is returned back to us. Even for the values of even the meta key value pairs are streaming as and when the response is ready. See, this is definitely much more responsive when compared to the other call without this particular fine-grained tool streaming value. So when you run this, it's also streaming, but it waits for each of the key value pairs to be prepared before it responds. See, it's waiting for the key value pair to be ready before the response comes back to us. Whereas here, by means of having this fine-grained tool streaming enabled, we can see that it's not waiting for the key value pair to be completed before it responds. So that's basically the main difference and the benefit of making use of this fine-grained tool streaming option that is available right now only in the beta variant of the Stream Context Manager. Okay, so let's look at a bit of theory to get a sense of what just happened over here. Let's look at the whiteboard. We know that from a previous video, whenever we make use of a Stream Context Manager to get the responses back, there are all these different types of chunks that come back to us. It starts with the message start, and then we have the content block start and content block delta. And the content block delta is the block that has these actual generated text. Okay, so it comes in pieces. So this is what we're used to from a previous lesson. We know that it sends all these different events back to us. We can even validate this in the code. So let's look at that right now. So here we have a call called streaming call without tool use. Over here, we are not providing any tools. So this is just a reminder of the feature that we had discussed earlier. The prompt also is not even asking to save it anyway. It says the prompt is just write a 200 words abstract for a paper about the benefits of using AI in education. That's it. It's just a simple article that it is going to produce. And it's just going to be all text. It's not doing any tool use. So when we run this, you can see that it just streams all the output back. And here you can also see that the different events that came back are in line with what we see in this diagram, right? So here we see the message start event, and then we see the raw content block start event, and then we see all the different content block delta events, which actually hold the text that is being generated. And then finally, we see the content top event. So this is what we are used to. We are already familiar with these events when we use a Stream API call without tool use. Now, with tool use, streaming call with tool use, when we do this, there is this new event that is going to come back to us. Here, we're going to just print the chunk itself. You know, we're not even worried about the different chunk type that comes through. We want to see everything. Okay. So here we'll run this, and you can see that along with the regular message start event, content block start event, we can see that now we have new type of event that is coming back to us. It's called the input JSON event. Now this input JSON event has these two values that are quite interesting. The first one is the partial JSON value. Here you can see the characters as and when they are generated and responded back. Okay? So these are the different chunks that make up our input JSON object. And then you also have this snapshot value, which is basically holding the snapshot of that JSON object as it is getting created. So the snapshot will contain all the characters that has been generated till now, and the partial JSON will have the characters that have been generated just now. So for example, in the next input JSON event, you can see limitation ons. The remaining part of this limitations word is over here. Okay, limitations in. Okay, and you have the snapshot. It still holds the entire sensible JSON object. So we have this new event that is coming back to us, and if you look at the whiteboard, you can see that when we turn on streaming the tools, the partial JSON will, as we just now saw on VS Code, basically it just streams the response as and when it comes. So initially the snapshot was just title, but then when vector came about, the snapshot is now title vector, and then when storage came about, now it's title vector storage. The snapshot has a more complete form of all the generated characters. So we are aware of this input JSON event that is coming when we are doing tool use. Now let's try to understand the difference between the streaming call with fine-grained tool streaming and without. Okay, so when we do a stream call without this fine-grained tool streaming, which is basically over here, we see that the key value pairs come only after they are fully generated. So that behavior is happening consciously because the Anthropic API waits for those individual chunks to form an actual valid key value pair based on the provided input schema. The input schema that we provide for the tool schema, right? So which is over here, the input schema, it defines that the abstract key should have a string value. So it waits for the key value pair to be valid based on the input schema. And only when at least one portion of a key value pair, it sends it back to our server. So that is the delay that we see. It is basically, even though the chunks are actually generated as partial JSON, Anthropic API waits to validate the key value pair, and only when valid, it sends it back. It is a bit of a safety measure that is available for us. By default, we can know for sure that the key value pair that is sent back to us is something in line with the schema that we have defined. Now, with fine-grained tool streaming, what happens is we are explicitly telling the Anthropic API, as and when you have a bunch of characters generated, just send it back to us. That's good enough, send it back to us. As more characters get generated, it gets sent back. The good thing here is we get immediate response. When we run this, you can see that it's not waiting for the key value pair to get completed before it actually gives us a response. It is actually streaming the response as and when the characters are generated. See, but the catch here is it will not do the schema validation. It doesn't check if the key value pair, the abstract key value pair or the meta key value pair is all valid based on the input schema that we gave. So it's just a trade-off that we would need to do. Whether we want it to be highly responsive, then we make use of this fine-grained tool streaming, which just streams back the response without validating the key value pairs. Or do we want that additional validation from Anthropic to ensure that we get the valid key value pairs at the cost of it introducing this slight delay? So these are the ideas that we learn in the fine-grained tool calling lesson of the Anthropic Academy course. And these are the two different ways in which we can stream responses back to us when using tools. One with the fine-grained tool streaming enabled and the other without. Thanks for watching, and follow along if you're exploring AI for your workflows.